Okay, guys, today, inshallah, we're going to continue what we started last time. Last session, we started talk about lesson 2 of chapter 19. We talk about the life cycle of the star, and who can remind me what are different stages of a life cycle of star? No one can remind me, guys? If you just remember, raise your hand. Yes, Hani?
First, it is a cloud of dust.
Yes, dust and gases. So
Yes.
so what happened?
And then there is gravity that pull them,
Yes,
that
good.
squeeze them.
Yes, which forced them to make a reaction known as
The nuclear fusion.
good nuclear fusion, in which hydrogen gases are, or the nucleus of hydrogen gases, just gonna merge together or fuse together, producing helium, and that's release an enormous amount of energy. Like this, we start the first stage of a star, which we call it the name of the stage. You don't know? Yes, Uta?
The main sequence star.
Yes, good. A main sequence star. So in the main sequence star, the energy which is produced from the nuclear fusion reaction is somehow equal to the gravity force, okay, that pulled the star. So the star appears to be bright and so on like this. So after the main sequence star, what would happen?
The hydrogen and
Yep.
the hydrogen atoms and the helium atoms will
So
fade until
yeah,
they make the red giants or
good.
the
Okay,
super
so
red giants.
good. We said that actually after the main sequence start keep doing this, and it would be in that stage for billions of years. Okay, at certain point the hydrogen gas will run out. Hydrogen gas could start to be like the fuel of the star, because due to the nuclear fusion, that the source of the energy or the radiation which is emitted by the star. So once the hydrogen run out or there is no more hydrogen, the nuclear fusion reaction will stop. And that case, the temperature of the star will start to drop or decreases. That will cause us, okay, the star to appear in red color. So we call it the red giant or super red giant. Okay, so why we call it giant? Because actually after the nuclear fusion, okay, just stop. So in that case here, the core of the star would be more denser, and a lot of gas will escape or just expand away from the center of the star. So that's why it appear giant. Okay, so depending on what it will gonna be, a giant or super giant red star. Okay, who can tell me? Depends on what.
Me.
Yes, okay, Uta.
It's a giant if the star is a medium or small size star, and
Good,
it's super giant if it's a large star.
good. Okay, depend or about the initial size. Okay, or the really what was the size of the star before it passed to this stage. That means if it was medium or small size star, it will make a super giant star. Okay, sorry, it will make a red giant star. If it was a big or a larger star, so it will create a super red giant star. Okay, so that's good here. What would happen next? Who can tell me? Anyone else, please, guys? Just share. Save your marks. Okay, already after the what is the third stage? Already it become as a red giant star. So what would happen later? Okay, just auto only.
I say.
What about the others? Just wait a minute. Okay, what about the others? Adham, Farah Mahlab, Hana Yasser, Laura, Dublina, Pomika. Yes, Farah?
It becomes a white dwarf in its the final step.
Yes, white dwarf star, which is
It's a
considered to
small
be
hot
the
star,
what?
which is a small hot star.
Yep. Okay. So it will gonna be a white, okay, dwarf star. So this white dwarf star, because after become a red giant star, okay, this will cause, okay, that the core of the star will keep making kind of reactions, but it will produce here, or there is no nuclear diffusion reaction. It will just create another elements, okay, which make it, okay, more denser, okay, and in that case, okay, it will be a smaller star, it's smaller in size, okay, and we called it the white dwarf star. That if it was a red giant star. What about the super, okay, red giant star that which we're gonna know today? But before past to this point, okay, we just need to know how scientists were able to study these stars and know about this. Okay, so what are the tools of studying stars? Okay, Okay, so we study stars, okay, by something or by a tool called the HR diagram. So what is HR diagram? Actually, there was a scientist. His name is uh, his name was Inwer, okay, Hertzberg. Okay, so the Inwer Hertzberg, that scientist, okay, it's a Danish scientist. This scientist start to collect data about different stars, and they start to compare the brightness of the star to its absolute magnitude, and start to draw a kind of graph that showed the relation between the brightness and the absolute magnitude. Anyone can tell me what is the absolute magnitude, guys? Anyone can remind me? Who can tell me what is absolute magnitude? No one except Ota.
I know.
Okay, Elor, just raise your hand, answer.
Sorry. It's the actual brightness of a star.
Yes, he just comparing the brightness of star to its absolute magnitude. That means he compared the apparent magnitude, okay, or sorry, the apparent magnitude, which is the brightness star, to its absolute magnitude, and start to draw this diagram. And also he compared the temperature of the star to its absolute magnitude. So he make a graph between the temperature and the absolute magnitude. In the same time, okay, or in the same age, actually, after after this work by 2 years, another scientist in another place, actually, okay, the Henry, okay, Russell, okay, so Henry Russell, okay, they make the same experiment. Even he doesn't know that already Hertzberg do that. Okay, he also started to collect the data about the temperature of different stars and their absolute magnitude, and they start to making a graph. Although both of them they were studying different stars, but they get similar results, which means that there is a fact here, okay, because both get the same result even they are working on different stars. So scientists start to merge the data and the results of these two scientists together, and they make a diagram. This diagram known as Hertzberg result diagram, or which is known as HR diagram. H as abbreviation for Hertzberg, okay, and R for Russell, okay. Or abbreviation for the result scientist, so we call the HR diagram. So what is the HR diagram? Actually, the HR diagram is a diagram that represents the relation between the temperature, okay, and the absolute magnitude here, okay. So as you can see here, just this, Isaac, how we could read the.
Mister,
Yep,
I was there.
I saw your conversation on the chat. Yes, Adam, don't worry.
Okay, thank you, Mister.
So here again, guys, this HR diagram, as we can feel like any diagram, we have an x-axis and y-axis. So here at down, you could find that in the range of the temperature, the different setting classes of the stars. Do you remember them? O, P, A, and so on. Okay. So as we move here, okay, to the right side, the temperature decreases, okay, while here on this axis that represents the absolute magnitude. So as we move up, the brightness increases, okay, because it gets negative signs, as you can know, okay, or as you can see here. So that's here how we could read it. So you can find in this HR diagram this line, which is represented in the light blue, this part we call that the main sequence, okay, star. That means what found here in that one. Look at the next page also. That's the rest of the graph. Do you imagine this, guys? In your textbook, you're gonna find both beside each other. You get this? Is it clear?
Yes.
Yes. So this red
Yes.
light, this red blue, okay, stream that represent the main sequence star. That means the stars which are located in that position, they are in the main sequence stage, okay. So here we find also that the stars which are, okay, bright, they are gonna be at the top, while the stars which are not bright, that will be down. And also we're gonna that the red giant stars, okay, or the stars that appear in the red color, they were gonna be on the bright side, okay, because already their temperature is less, okay, while that blue stars or the hot star, they are gonna be on the left side. So that's here like in a graph. So as we can say, as we move up, the brightness increases, and as we move right, the temperature decreases. So the hottest bright star, they are gonna be at the left top, while the coldest and dim star, they will be at the right down. So here let's find what is. So these are not found in the main sequence stream. So that means these stars actually they are not in main sequence stage. They already turn to be a white dwarf. So as they are white dwarf, you can see they are not bright anymore. Okay, because they lose the ability to make the nuclear fusion reaction, and as you can see, their size compared to the other stars considered to be too small. That's why we call them dwarf stars. You get this, guys? Okay. Is it clear?
Okay.
Yep.
Yes.
Okay, here you can find, okay, that's all these stars actually, they are in the main sequence star. That means these stars, they still able to do the nuclear reaction, or they can able to make the nuclear fusion reaction producing this kind of radiation, okay? And you could find these stars, okay, they could keep shining, or they could be in this stage for billions of years, okay? So the approximately time estimated for these stars is about 5 billion years, okay? So here you could find that our sun, for example, let's see here, that's our sun. Sun is considered to be in the main sequence stage, okay? So the sun is average star, its size is considered as average star and found in the main sequence stage. So it's still able to radiate or make the nuclear fusion reaction and radiate these different radiations. While here, these stars actually, what we can consider this star, are they are in the main sequence?
No.
So what do you think? They are in which stage, guys? This one. Okay. What do you think? Yes, Uto? Do you know?
Can you repeat? I didn't hear the question.
Again, we said that these stars which found in the light blue area, they are in the main sequence stage. So if they are in not the main sequence stage, what do you think? What they in which stage they are? Guys, what do you think? Yes, Farah Mahlab?
Red giants or
Yes.
super red giants?
Yep, good. Okay, regarding to their color at temperature, the temperature is low, so that means they start to turn into the red color regarding to the sequence here of the temperature. And their size, as you could observe, they are big, so they could be a red giant or a super red giant, okay, star. So here, they are in the second stage, okay? So that means this stars somehow they start to lose the ability of making, or they lose the ability of the nuclear fusion reaction, okay, and their temperature decreases, okay. So for example, here you can find these stars are the giant and the super, okay, giant stars, okay. And here we have some red dwarf stars, okay. So these red dwarf stars, they were a white dwarf stars, but later they start to lose their temperature gradually, so they even turn to be a red color, okay. So how that we are able to read the HR diagram in her question here, guys?
Oh no.
Okay.
No.
So here, like this case, that's how we are able to, or that's how we could know by looking at the HR diagram, we could know the temperature of the star, or the average temperature of the star. We could know its absolute magnitude, that means its brightness, and even we could know this star in which stage of its cycle. So like this, the HR diagram considered to be useful to know a lot of details about the stars. Okay. So last time, guys, do you remember the video that we watched last time? Okay.
Yes.
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 So in the video which we watched last time, we already know the first three stages, or the sequence that the star passes through: the main sequence star, then the red giant or super red giant star, and finally the white dwarf star. And we said that white dwarf star, that the stage which the star, okay, or the red giant could pass to. What about the super red giant? Is it also gonna make a white dwarf star? Actually not, it will have a different sequence, okay. So what is it? Let's remember, okay, and watch the video one more time. Just wait with me here.
Movies an Oscar? A star on the Hollywood Walk of Fame? No, that's a different kind of star. I mean stars found.
Okay, guys, just a minute here. Okay. So I just picked the video because that was not the last video. Okay, so. Okay, guys, that's it, the idea. If it's a red supergiant star, as you can see, okay, so this red supergiant star, it's still because already it lose the hydrogen and it's not able to make the nuclear fusion between hydrogen or gases to produce helium, but still make a kind of nuclear fusion between different elements that create some elements which is heavier even than iron. So once the collisions or that kind of fusion happen, this start to emit radiation. Sometimes, okay, this radiations become too big to make a very great explosion that could even pass through the space. Okay, we call this explosion is a supernova. Okay, so actually supernova could be observed even, okay, from different far objects because it's a very huge amount of energy is emitted. Okay, so like this, okay, after this kind of explosion happen, okay, the most material which found in the star are expelled outside. Okay, that means they already escapes from its gravity. So that's which make the inner core of the star become more denser and highly compacted to each other. Okay, so that will lead to formation of neutron star or black hole. Again, that depend on the how big the star is. So if the star was just big, okay, that will make a neutron star. So neutron star, it is very dense core, okay, that you could observe here. And sometimes this neutron star may have the ability to move in a spiral shape, or it just spins around itself. So we call this the pulsar. Okay, so the neutron star wasn't able to spin. We call this a pulsar. And sometimes, okay, if the star was very, very big, okay, this collapse or this kind of explosion, okay, will make the internal core of the star collapse on itself, which create a massive gravity that is able to attract anything. So we call it a black hole. Actually, we just call it black hole, or we cannot see the black hole, but we detect it, okay, by its ability to attract the surroundings. That means it even could attract some meteorites, some materials, even smaller stars that are found in that area. They able to attract their dust, okay, and their gases, okay, or their atmospheres, okay. So that is the idea of black holes. So any hard question in that part, guys?
No.
Okay, so let's back to here to our this part. So as we said here, okay, the super red giant star, okay, so massive stars, okay, once the hydrogen run out and they turn to be a super red giant star, they could be able to make a kind of explosion that emits a lot of energy. We call this explosion the supernova. Okay, so we said that a supernova, it's a massive explosion in which a massive star collapses and throws out the layers into space. This explosion emits a lot of energy that could be observed within the space. After that, okay, the star, if it was big, it will just collapsing and create a high dense core. Okay, we call this the neutron star. If the neutron star is able to spin, so we call that pulsar. But if that star was very big, it will create a black hole. So any hard question regarding to today's lesson, guys?
No, mister.
Anyone can't understand any point?
No, thank you.
Everything is clear, guys, here?
Yes.
Yes.
Okay, so please study this part very well from your textbook. Okay, answer your section review, and just check the SMS regularly, because we are gonna just upload or post about the project, and also if there is new sheets or something like this. So please, guys, study this part very well, and if you have any question, you can send to me anytime. Thank you, guys, and goodbye.